Let's have a closer look at how the DRS system in F1 works. The rear wing in F1 consists of two elements, the main plane and the flap. The drag reduction system, DRS, opens the flap on the straight under certain conditions, which reduces downforce and drag. But until today, F1 teams use different designs for their DRS systems. What all of them have in common is that it's operated with hydraulic pressure and it has a gas spring to push the flap back into the closed position. But there are three different DRS designs we can see across the grid. 1. The rocker design. This design has a triangular rocker element. It is fixed to the DRS pod foot, the hydraulic element, and to a link that is connected to the flap. Advantage of this system is that the flap is always operated from above, so it can be pushed into the closed position if necessary. So it's a more reliable and safe design. Disadvantage is that the mechanism is pretty big, which creates a large DRS pod, which in return creates more wake. But you can also use this large mechanism and still design a small pod around it with elements sticking out, like Renault and Alpine are doing. System number 2 is a straight connection from a fixed hydraulic element to a link that is connected to the flap. Advantage here is that, because the hydraulic element doesn't move, the DRS pod can be very slim and it creates very little wake. Disadvantage here is that the flap cannot really be pushed back into the closed position, so you have to choose a DRS angle where the flap still generates enough downforce when open, so that it can return to the closed position. So the slim pod gives you a tiny aerodynamic advantage, but you might compromise your DRS angle, and if something goes wrong, you cannot push the flap back into the closed position. So most of the teams chose system number 1. The third system is a direct connection from the hydraulic element to the flap, very similar to number 2. But here we don't need the link anymore. Advantage here is that it needs less parts since the hydraulic element is directly connected to the flap. But the disadvantage is that because of the movement of the hydraulic element, this system requires a large DRS pod too, just like number 1. And it also cannot really push the flap back to the closed position. So this is simpler, but it has the disadvantages of number 1 and number 2 at the same time. To reduce the wake of the DRS pod, Mercedes used the spiky edge. Now, a Formula 1 car should be as light as possible and components are always optimized for weight saving. So is the flap too. But in order to avoid bending of the flap in open position, which by the way caused the massive Ericsson accident in Monza, teams designed this center support. If you want to know more about this particular center support, check out my other video and the link in the description. Red Bull showed us quite impressively what happens if the flap has a center support, but not enough stiffness across the span. In Brazil this year, we could see Verstappen's wing oscillating on the straight in open position after the car hit a bump. We see that the outboard trailing edge and the center leading edge are fixed, but the rest of the wing is wobbling about. What happens here? Because of the bump, the outboard leading edge bends slightly upwards, which creates lift, which bends the flap even more. At some point, the flow on the pressure side of the flap collapses and separates. It creates less lift, and the flap bends back down. Then it snaps back, etc. Oscillations like this are hard to engineer for your own advantage, since they also depend on weather conditions. If anything, they damage your wing assembly and literally shake it apart. How do you like the DRS system, and are you looking forward to see it next year on the cars? Let me know in the comments below.